Hello everyone, welcome to the 22nd January 2025 question paper on mains, and that was conducted on noon. Let's start with the first question. A symmetric thin biconvex lens is cut into 4 equal parts by two planes A, B and CD as shown in the figure. Original power of the lens is 4D, then the power of the part of the divided lenses. You can see that the lens has been divided into two parts. Horizontally and vertically. The horizontal division will not change the focal length or the power. It will not change anything, but the vertical cut would actually change the power. You can see if a lens is cut vertically, the power of the lenses will become exactly half of what it was. What is the power? 4D. It will become 2D. Each will become 2D. And if you cut it like this, there won't be any change. It will simply remain 2D and 2D. Clear? We just got 4 lenses. That's it. Clear? Each one 4D. So then the power of the part of the divided lens is, the answer is 2D. A rigid spherical ball of mass m is dropped in a long vertical tube containing glycerin. The velocity of the ball becomes constant after some time. If the density of the glycerin is half of the density of the ball, so density of the glycerin is half of the density of the ball, then the viscous force acting on it will be. See, if a ball, the moment you know that the ball is moving down with a constant velocity, it means that it is going to undergo a terminal velocity. That is going to be a terminal case. If it is a terminal velocity, then net force acting on the system should be 0. So what are the forces acting? Well, there is mg, there is buoyancy force, and there is viscous force. Fv. And we can say that these are all balanced, so we can say mg is equal to Fb plus Fv, and we can say the viscous force which we need to find is mg minus Fb. And we know the buoyancy force is equal to density of the solid, density of the liquid, the glycerin, into volume of the solid into G. And we know density of the glycerin is half the density of the ball. So density of the ball, velocity, volume of the, we can write it as volume of the ball here into G divided by 2. So you can see this is going to be mg divided by 2. This is going to be the mass of the ball. Clear? So we get the answer mg minus mg by 2. This is going to be mg divided by 2. Well, that is the answer. Option 2. Next. The maximum percentage error. Just a little calculation is there, nothing else. They have given what is they are asking what is the percentage error in the density of the wire. How do you write the density? Well, density is equal to mass divided by volume, correct? And how do we expand this? Well, mass is equal to density into volume. Volume is equal to, well, this is a wire, so we can write it as pi r square into L. Clear? Pi r square into L. Now let us find the fractional error in all of this. So fractional error in the, what are they asking? Okay. They are asking the fractional error in the density of the wire. So we can write density is equal to mass divided by pi r square into L, which we can write delta d by d is equal to delta m by m plus 2 times delta r by r plus delta L by L. Just for convenience, I am keeping it like this, density on one side, remaining on the other side, and then finding the answer. Even if I had rewritten it, it won't make a difference, but make sure that all the errors are added. That's all. Clear? You should not get a minus sign in between. Everything need to be added. Okay, so delta m by m, now let us substitute all these values. Delta m, you can see 0.03 divided by 0.6 plus 2 times delta r by r, well, that is 0.01 divided by 0.5 plus delta L by L 0.05 divided by 10. Everything multiplied by 100. 0.3 by 0.6 will be 1 by 2, correct? 100 if you borrow over here, it will become 0.3 by 0.6, which will be 1 by 2 plus. So I'm trying to simplify it as much as possible. This is 1 by 0.5. We know 0.5 is half. 2 goes upstairs, it will become 4 plus, and if you multiply with 100, it will become 5. 5 by 10, well, that is 1 by 2. Half is 1, we get 5, and that must be the answer, 5%. Done. Clear? Question number 3 is done. Let's go for question number 4. See, a series LCR circuit is connected to an alternating EMF E. Current amplitude at resonant frequency is I0. Current amplitude at resonance is I0. And we know if current amplitude and resonance word is written over there, we know the I0 is equal to V0 divided by Z, and where Z is equal to R. If the value of the resistance R becomes twice of its initial value, resistance is made twice, then amplitude of the current at resonance again. Clear? Again at resonance. So that means if the value of the resistance has become 2 times, so I dash is or I is equal to, we can write V divided by 2R. And we know that what is V by R? That is I0. So the answer is I0 divided by 2. It's a very straightforward question. Clear? Nothing else. Just they have asked what is the amplitude of the current when the resistance changes over there. And they have taken the same condition, resonance. Moving on. Okay. For a short dipole placed at origin, if a dipole is placed at origin over here, there is a dipole placed, direction is this way. If the electric potential and electric field at A are V0 E0, at A, electric field and potential is given E0 and V0. Let's do one thing. We are definitely, as the question progresses, you can see that they are asking what is the electric field and potential at B. That's what the question is. Clear? So I am going to do one thing. At point A, they have given the electric field is E0 and potential is V0. I will write the expression directly over here. That will be electric field E0 is equal to 2kP divided by R cube, and potential V0 at that point is equal to Kp by R square. This is the expression. Clear? And now at point B, which is the equatorial axis, what is the potential? Potential is 0. No doubt about it. Along the equatorial line, potential is going to be 0 because that point will be equidistant from these two, the dipoles, minus q here plus q here. The moment you see a dipole moment in that direction, you should imagine minus q and plus q charges over there. Okay, so what is the electric field at that place? Well, that is equal to Kp divided by R cube, but wait a minute, be careful, it is 2R and this is R. So if it is 2R, that will become 8R cube. 2R the whole cube, so 8R cube. So electric field becomes exactly E0 divided by 8. So at point B, electric field become E0 by 8, and it's not E0 by 8, right? You can see it is 2 Kp by R cube, won't be E0 by 8. So I will do one thing, I will write it as 2 Kp by 16 R cube. So what is that going to be? 2 Kp by R cube is what we call E0. So the answer is E0 divided by 16. So what is the answer? Potential is 0 and electric field is E0 by 16. E0 by 16. That would be the answer. Okay, moving on. Capacitance is given. We had to find what is the dimensional formula of capacitance. C is equal to Q by V. Start with the equation. They have given C as the coulomb. Clear? So they have used the fundamental unit as coulomb over there for the charge. So we can write Q, or can I say this is potential is work done per unit charge. Potential difference is work done per unit charge. So I will write it as Q square divided by W. Q square is Coulomb square, and work done is force into displacement. Force is mLT minus 2 into displacement, that is L. So the final expression becomes m goes upstairs minus 1, L become L square goes upstairs L to the power minus 2, T to the power 2 and C to the power 2. Well, we are searching for this equation. Where do we find that C square m to the power minus 1? c square m to the power minus 1 L to the power minus 2 t square. Option 4. Clear? A very easy question. All you have to be careful about is the equation you have to use, and rewrite each of the terms over there and then rewrite it into fundamental terms and substitute the value. There you go. That's the answer. Clear? Next one. An electron projected perpendicular to a uniform magnetic field B moves in a circle. Electron projected perpendicular to uniform obviously moves in a circle. If Bohr's quantization is applicable, then the radius of the electron orbit in the first excited state. What do you mean by first excited state? First excited state means n equal to 2. Okay. And the radius, we can say radius, if it is moving in a circle, is going to be r is equal to mv divided by qb. We want the expression of radius over here. We don't want velocity in the expression. So I know quantization tells us L is equal to mvr, and that is nh by 2 pi. N is equal to what? 2. So this will get cancelled, right? So V is equal to h by m r pi, and r is equal to m by qb into V, that is h by m r pi. M gets cancelled, so r square is equal to h by pi qb, and so r is equal to root of h by pi. We know it is electron that is moving, so E into B, h by root of h by pi ab. Option 4. Clear? That's it. Moving on. Okay. For a diatomic gas, gamma is equal to gamma 1 equal to Cp by Cv for rigid molecule, and gamma 2 is equal to Cp by Cv for another diatomic molecule, but also having vibrational modes. So this one has a vibrational modes in it, the other one doesn't have. Clear? That means that this is done for a higher temperature, that's why it has vibrational modes. Which one of the following option is correct is the question. So we just have to figure out the gamma value. So gamma 1 is 1 plus 2 by f. They are asking us to compare the gamma. So degree of freedom for the first case is 1 plus 2 divided by, if it is diatomic, there will be 3 translatory, 2 rotatory. So that is total 5. And if it is gamma 2, oh wait, this is going to be 7 by 5. For gamma 2, it is going to be 1 plus 2 divided by degree of freedom, 3 translatory, 2 rotatory, and plus 2 potential energy terms because of the vibration. Kinetic energy plus potential energy will be there when it comes to vibration. So there will be 2 added from this, so 7. So the answer is 9 divided by 7. So whichever is the higher value. 5, this value will give us 5 1s are 5, 5 4s are 20. This is 9 1s are 9, 7 1s, 7 1s are 7, 7 2s are 14, and 7, I think it will come, yeah, so 1.2 something we are getting. So if you compare them, you will see that gamma 1 is greater than gamma 2. Gamma 1 is greater than gamma 2. There you go. Option 4. Clear? Next. A rectangular metallic loop is moving. A rectangular metallic loop. Okay. There is a rectangular metallic loop moving in a magnetic field at a constant speed. It is moving in a constant speed when the loop is partially inside. So the given situation is, it is partially inside a magnetic field. So there is a magnetic field region and it is partially inside that field. The plot of magnitude of induced EMF with time is equal to. You're pulling out a square plate in a magnetic, you can see you're pulling out a square plate. So that means okay, all right. So if I pull it slightly over here, so the area that is going to cover, let's say this much is the area that it covers, So induced EMF is equal to d phi by dt, correct? And phi we can write it as rate of change of fluxes, magnetic field which is not changing, but the area is changing, correct? No, area is changing. So area I can write the tiny area that it covered in, let's say this is the area that it covered in a time of dt. What is the area? Let's say the length is dx and the length is L. So we can write the area of this tiny portion covered in time dt as L into dx. So L dx by dt. And you can see that is equal to BLV. BLV. And you can see that is constant because now everything is constant. Magnetic field is constant, length is not changing, V is constant. So what is the option that we need to pick? The answer is option 4. But instead, think about it, instead if it was a circular loop, you can see that the area will keep on changing actually over there. Clear? So area covered per unit time, initially it will increase, at the middle it will be maximum, and then it will start decreasing over there. So the graph won't be that. Okay. So in the NCERT, they have actually given an explanation to it. So please check that out. A source of light of wavelength lambda illuminates a metal surface and electrons are ejected with maximum kinetic energy 2 electron volt. If the same surface is illuminated by a light source of lambda by 2, maximum kinetic energy ejected will be work function of the metal is given. So that means Hc by lambda gives work function 1 plus the kinetic energy that it gives is 2 electron volt. That means the answer is Hc by lambda equal to 3 electron volt. That's the answer. Okay. If the same surface is illuminated by a wavelength of lambda by 2, now the equation becomes 2 Hc by lambda. Lambda by 2 goes upstairs. Work function does not change. Maximum kinetic energy will be K max, which we have to find. We know Hc by lambda is 3. So this will give you 6 equal to 1 plus K max. And what is the maximum kinetic energy? Maximum kinetic energy is equal to 5 electron volt. The answer is option 3. Clear? Moving on. Okay. Pick the right expression. A simple pendulum is taken to a planet of mass m and radius 4 times and 2 times respectively than the Earth. Time period of the pendulum remains same on the Earth and the planet. See, if you take a pendulum from Earth to another planet, you can see time period of a pendulum, it depends on length and gravity. So we have to check whether the gravity has changed or not. In some other planet, G in the planet is equal to what? G m by r square. What is happening to the mass? Mass has become 4 times. So 4m divided by radius has become 2 times. 2r the whole square. And this you can see gravity of the planet will become equal to gravity of the Earth. So that means length does not change, so everything remains the same. So time period in the planet and time period on the Earth will remain the same. So first statement given is correct. Mass of the pendulum remains unchanged at Earth and the other planet. Yes, mass of the pendulum does not change whether it is on the Earth or the planet. What will change? Gravity value will change. That means the weight will change. Clear? So mass doesn't change. This statement is also correct. But again, that is not the correct reasoning over here. Clear? That is not the correct reasoning. So that means we can say the answer is option 1. Not. Clear? Not the correct explanation. The correct explanation would have been if the weight changes. Clear? If they mentioned the weight changes. Torque due to the force is given acting on a particle whose position vector. This is a very straightforward question. All you have to do is I, J, K, tau is equal to R cross F. R comes first, 1, 1, 1, 2, 1, 2. And now cross multiply it, you will see the answer is 2 minus 1 into I cap minus 2 minus 2 to j cap plus k cap into 1 minus 2. Well, the answer, final answer is I cap minus k cap. I cap minus k cap, option 3. Alright. Force is given, displacement is given. What will be the value of B if work done on the particle is 0? What is the work done on the particle? Work done is force into displacement. Take the dot product between them. You'll get 2 I cap, that will give you 2. B and minus 2, that will be minus 2B. 1 and minus 1, that is minus 1. This equal to 0. You end up getting 1 minus 2b, 1 is equal to 2b at b equal to half. Option 2. Clear? Next. Again, in Young's double slit experiment, the fringes produced by red light are closer as compared to that of the blue light. How do you write beta? Beta is equal to lambda d by d. Beta is directly proportional to lambda, and lambda for the red is more than that of the blue. So that means beta of the red should be greater than beta of the blue. So whatever the expression they have given is wrong. Red, it is closer they have given. So that statement is wrong. Fringe width is directly proportional to wavelength of light, and that is correct. So the answer is A is false, R is true. A ball of mass 100 gram is projected with a velocity 20 meter per second at 60 degree with horizontal. The decrease in kinetic energy of the ball during the motion from the point of projection to the highest pointers. From the point of projection, then when it reaches the highest point, you can see the velocity at the highest point is u cos theta, and the velocity, initial velocity over here is u, making an angle theta. So the kinetic energy we can write is half m u square cos square theta. This is the final kinetic energy, and initial kinetic energy is half m u square. So the change in kinetic energy, I always prefer to write the equation first, and then only I would like to substitute. As much as possible I try to stick with this. So half m u square into 1 minus cos square theta. Now if you substitute, half into 100 gram would mean 0.1 kilogram into u square, that is 20 square, that will be 400. 1 minus cos 60 is, this is 60 degree with horizontal. Always check that. Clear? If it is 60 degree with the horizontal or 60 degree with the vertical, always check that. So 1 by 2 the whole square, 1 by 4, and this will give us, this will be 200 into 0.1 is 20, and this will give me 3 by 4. 4 5s, and I will end up with the answer 15 joule over there. That's the answer. Clear? That's it. So here you have a question. A transparent film of refractive index 2 is coated on a glass slab of refractive index 1.45. What is the minimum thickness of the transparent film to be coated for maximum transmission of green light of wavelength 550 nanometer? That's the question. So you, without having any knowledge on the thin film, you will not be able to crack this question. So what they have given us, they have made sure that light is falling over here and getting reflected. Light is falling over here and getting reflected. A part of the light, remember, is also getting transmitted through it. Clear? The light is also getting transmitted. So we have to maximize the transmission over here. So what should happen? The light ray, the green light should undergo minimum reflection over here. Correct? So that means it should obey the condition of minima condition over here. So the condition would be this. Let me say that this is going to be source S1 and this is S2. And the thickness over here is T. The refractive index is mu, which is equal to 2. And this is equal to 1.45. Let us call it mu1, mu2. And let us find what is the answer. If I draw perpendicular over here and a perpendicular over here, this particular path, if this is R, this part is going to be thickness. This length is going to be T cos R. But we have to take the optical length. Clear? This extra distance covered is T cos R, but we have to take optical length. So that means we have to multiply with the refractive index. Same thing happens over here also. This is also going to be mu into T cos R. Okay. So let us write the equation. S1, S2P, the path difference is going to be, let's say the wave meets, both the waves meet at a point P. So wave is coming from here, hitting, reflecting, and then reaching there. S2P hitting and then reaching over there. They are meeting at a common point. So I can say S2P minus S1P. That's a small correction. That is S1P. Oh, all right. It's the S2P. So, sorry. S1p is traveling longer when compared to S2. So I will write S1p. This one travels a little longer than this, but because the light is traveling from rarer to denser and undergoing reflection, it will undergo a path difference of lambda by 2. Clear? Extra path difference of lambda by 2. So we have the condition S1p minus S2p plus lambda by 2 is equal to minimum condition. I can go either with n minus half lambda or plus half lambda. So always choose in a way. For example, look, if I open the bracket, I will end up with minus lambda by 2. So you do one thing, you choose half over there, minus half lambda over there, so that that will get cancelled. Clear? So then we get the equation S1p minus S2p is equal to n lambda. Clear? This is the expression. Now S1p minus S2p, what is that extra path covered? 2t mu cos r. Cos r, they have already said it is a nearly perpendicular. That means the r value is very small. R is small. That means cos 0 is 1. So we get 2t mu is equal to n lambda. We will take the first one, first order, n equal to 1. So we get the thickness is equal to lambda by 2 mu, which is lambda by 4. And 550 divided by 4, if you divide, you will get the answer as option 3. Clear? That's it. So please be very careful. We have to know this. I have explained each and every case over here, how it happens, what do you mean by path difference. S2p, S1p. You can see S1 has traveled longer than the other. So S2p, S1p minus S2p. But again, no, we had to account for the path difference also. Here there is no path difference. Why? Because you can see it is 2 and this is 1.45, denser to rarer. Light travels from denser to rarer, no path difference is introduced. But if the wave is traveling from rarer to denser, it will introduce a path difference of lambda by 2, and that has been included over here, and that is equal to n minus half lambda. I have already explained why are we choosing minus half lambda over there, so that we can cancel these off. You can see this is your choice. You can put n minus half or n plus half. Try to express it as simple as possible. If I had actually taken plus half over there, nothing wrong. You will get n plus 1 over there. Clear? Try to avoid something like that. There you go. Clear? So 137.5. Moving on. Again, very straightforward question they have asked. They have said that the radius over here is 2 centimeter, radius over here is 1 centimeter, and velocity of the water entering the point 1 is 2 meter per second. They are asking what is the velocity at this point. How do we solve it? We can say A1V1 is equal to A2V2. What is the area of the first part? 2 square, 2 centimeter square. That will be, alright, that is, okay. 2 centimeter square, that will be 4 centimeter. 2 centimeter the whole square, that will be 4 centimeter square, into, what is the velocity over here? 2 meter per second. What is the area on the other side? 1 centimeter square, that will be into V2. So what is V2 equal to? 8 centimeter per second. Yeah, the answer is 8. That's weird. The answer should have been, oh, the velocity is 2 meter per second. All right, my bad. The velocity is given 2 meter per second. So the answer will be in meter per second itself. So the answer is 8 meter per second. Yeah. Centimeter will get cancelled. Moving on. Okay. Extensive property and intensive property. What is an extensive property? Extensive properties are those which will depend upon the quantity over there. For example, if you take pressure, internal energy, volume, mass, and temperature, if I cut the system into half, if I take it in a container and take a container which has definite pressure, internal energy, V, M, and T, and I cut it into half, which of the following quantities will become exactly half? Let's check. If I take half, we can see, let's start with the temperature. If I take the quantity half, will the temperature change? It will remain the same. If I cut the entire volume into 2, entire system into 2, you will see the mass will become half. Volume will also become half. What about the internal energy? It's sum total of all the energies over there, right? So if I cut it into half, half of the molecules are gone. So half of its internal energy is also gone. So internal energy also will become half. The pressure of the gas is the force exerted by the molecules with the container. Clear? If I cut it into half, if I take only half of it, you will see the pressure would just remain the same in both the containers. Clear? So that will remain same. So which are the extensive property over here? Mass, volume, internal energy. Mass, volume, internal energies are extensive property. What are the intensive property? Pressure, temperature. Anything else is given? Pressure, temperature, density. Oh, we can include density here. And density, what will happen to density? Will it change? No, it will remain the same. So again, you can see this, and this. Pressure, temperature, density. Pressure, temperature, density are intensive variables. Clear? So the answer is option 3, A and B only. Moving on. A body of mass 100 gram is moving in a circular path of radius 2 meter on a vertical plane as shown in the figure. Velocity of the body at point A is 10 meter per second. Ratio of the kinetic energies at B and C is. Okay, nothing else has been mentioned. Radius is given as 2 meter. Fine. So at this point, okay, at this point it is given a velocity of 10 meter per second. So here it is 10 meter per second. So let us check. What is the velocity at different points? Velocity at different points is simple. U square minus 2gr or L into 1 minus cos theta. So at the bottom we know what is the velocity. Let us find the velocity at point B. An angle that we are looking at is the angle measured with respect to the vertical. So what is the answer? Root of 100 minus 2 into 10 into length is equal to radius is 2. So there you go. 1 minus cos theta. What is cos theta? Cos root 3 by 2. Because cos 30, root 3 by 2. So there you go. So VB square is equal to 100 minus 40 plus 40 into root 3 by 2. So here I will end up with the answer 60 plus 20 root 3. This is VB square. Okay. Because I need kinetic energy, so I am okay with taking it as VB square. And what is VC square going to be? VC square is equal to once again U square minus 2gl into 1 minus cos theta. U square we know it 10 square, which is 100, 2 into 10 into 2 into 1 minus cos theta. What is the theta now? 90 plus 30. Clear? Total angle is 120. What is cos 120? Minus half. So plus 1 by 2 here. That is 3 by 2. One of the 2 will get cancelled. So let's write it as 20 into 2 into 3 by 2. 60, 40 here. 60 and you get 40 here. All right. So what is the ratio of the kinetic energy? Now I think it's much easier. But let's take the 20 outside. 20, you will get 3 plus root 3. So let's take the ratio. Ratio of the kinetic energy at point B to the kinetic energy at point C is equal to half m gets cancelled. VB square and VC square. That is going to be 23 plus root 3 divided by 40. That is equal to 2. The answer is 3 plus root 3 divided by 2. 3 plus root 3 divided by 2. Option 3. Clear? A proton is moving undeflected in a region of crossed electric and magnetic field. If you ever see these words like, a proton is moving undeflected in an electric and magnetic field, that means it has to be obeying one condition, that V is equal to E by B. Clear? V is equal to E by B. So that means we know the ratio of E by B. E by B is how much? 2 into 10 to the power 5. When the electric field is switched off, that means the only magnetic field exists. Proton moves in a circle of radius 2 cm. So that means the radius is going to be mv by qb, and radius is given as 2 into 10 to the power minus 2. And this is proton, so we know the mass and we have the charge also. Magnitude of electric field is x into 10 to the power 4. Mass of the proton is given. Okay. So have they given the velocity? Yes, they have given the velocity. All right. I think we can substitute the value of, instead of magnetic field, which they haven't given, I can say B is equal to E by V. I can substitute it. R is equal to M V by Q into E divided by V. That will become V square here. So what is the electric field? mv square by QE into R. What is mass? We are talking about proton. So 1.6 into 10 to the power minus 27 into V square. That will be 4 into 10 to the power 10 divided by 1.6 10 to the power minus 19 into, well, the electric field doesn't come here, into the radius. What is the radius here? It is 2 centimeter. 2 into 10 to the power minus 2. 1.6, 1.6. So those headaches are gone. This will give us minus 19 and minus 27 will give us minus 8. This will give me 2. So the final expression will be 2 into 10 to the power, this will give me 10 to the power 2. Minus 2 goes upstairs, 10 to the power 4. So 2 into 10 to the power 4. So the answer, x is equal to 2. That's it. Clear? Moving on. Two long parallel wires, x and y separated by a distance 6 centimeter. Okay, x and y separated by 6 centimeter. Currents are in opposite direction. Magnitude of resultant magnetic field at the point P, it is outside. P at a distance of 4 centimeter from y is x into 10 to the power minus 5. So we have to find the value of y. So we have an infinitely long wire. First figure out what is the direction of magnetic field at the point P. If this is an infinitely long wire, you can see that my fingers are curling inward. So current is upward and my fingers are curling in. It is entering here. Clear? Since it is entering, we can say the first magnetic field is cross magnetic field B1. And magnetic field, because of the other, you can see it's downward. So you can see the fingers enter from here and then come out from here. Fingers, you can see the current direction is this. Fingers enter from here and come out from the other side. Since it's coming out, we can put it as dot magnetic field. That means magnetic fields are in the opposite direction. And B net is equal to B1 minus B2. B1, and what is B1? Mu naught. What is the magnetic field because of an infinitely long wire? The answer is mu naught I by 2 pi into R1 minus mu naught I, this is I1, I2 divided by 2 pi R2. And so mu naught by 2 pi into I1 by R1. So let us find what is I1, 5. 5 by R1. What is the distance? 6 plus 4, 10 centimeter. 0.1 minus 4 divided by 0.04. Mu naught by 4 pi, we know mu naught by 4 pi is 10 to the power minus 7. So this must be 2 into 10 to the power minus 7 into, well, this we can write it as 4 by 0.01, and I can simplify it as 50 here, multiplying 10 on both the sides, multiply 100 on both the sides, so you will get minus 100. Done. So you get minus 50 here, minus 50, and that is minus 100 into 10 to the power minus 7, which will give me 10 to the power minus 10 to the power minus 5. And I ended up getting a minus sign over here, which means I have made a mistake in writing the expression. Yeah, I am wrong about saying that magnetic field because of B1 should be greater than B2. Clear? So clearly you can see magnetic field B2 is bigger than B1. That's why I ended up getting a negative sign. That's it. So the answer is, you can see they have given 10 into minus 5. So here you are getting number 1. So 1 is the answer for 47th question. A parallel plate capacitor of area 16 centimeters square, separation between the plate is 10 centimeters, charged by DC. Consider a hypothetical plane surface of area A0 equal to 3.2 centimeters square inside the capacitor parallel to the plate. At an instant, the current to the circuit is 6 ampere. At the same instant, displacement current A0 through A0 is. We have to find displacement current through A0. See, it's a very simple situation. Current is, they are trying to trick you. They have given the conduction current over here as 6 ampere. Remember, if they give you conduction current, then the displacement current that happens over here, because you can see that when the current is flowing in the circuit, it is going to add the charges on the plates of the capacitor. Because of the added charges over there, the electric field over here keeps on changing. So the change in electric field over here would represent the current in that displaced region. That is what we call displaced current. And at any instant, IC is equal to ID. That means the displacement current is 6 ampere. And this 6 ampere displacement current is is completely between these particular plates of capacitor. And the area is given by 16 centimeters square. So that means 6 ampere current is passing through that area, clear? Area of 16 centimeters square. And what is the current passing through? 3.2 centimeters square is the question. Clear? What we can do, 6 by x by 6 is equal to 3.2 by 16. So x is equal to, well, this is going to be 16 and 32. That will be 2 times, but 0.2 here. So x is equal to 1.2. And so we want it in milli, so that means it is going to be 1.2 into 10 to the power 3 into 10 to the power minus 3. Clear? So 1200 milliampere current. Okay, so 1200 is the answer. Moving on. A tube of length 1 meter is completely filled with an ideal liquid. So there is a tube that is filled with liquid, completely filled with ideal liquid over here, and closed at both the ends. Tube is rotated in a horizontal plane about one of its ends. So this is the end about which it is rotating. If the force exerted by the liquid at the other end is F, then the angular velocity is. You can see that, we can consider this as one rigid body. Clear? One rigid body. If it is considered one rigid body, if it is rotated, you can see the liquid is stable inside. The liquid is rotating in about an axis over here. Clear? It is rotating about an axis. So we have to find what is the force exerted over here. So don't you think the liquid is trying, if this was open, the liquid would be flowing out. Clear? So what is preventing it? This wall. So that liquid is exerting a force on the wall exerts a force back, and that force will be in this direction. That force will be in this direction. And how much is that force? That force is enough to give the centripetal force. Clear? So centripetal force, that should be providing the centripetal force for that entire liquid. But if you notice, the centripetal force required for the tiny piece of liquid over here and any part of the liquid that you consider over here will be different. The centripetal force required for the end at the extreme end over here, the centripetal force required for the mass, the tiny mass at the extreme end over here should be maximum. And as we move from the one end to the other end, the centripetal force keeps on dropping. Clear? So how much is the centripetal force required? So for that we need to integrate it. Clear? So after integration and all, you take a tiny piece over here at a distance, we can call it as x, and the size is dx, and the centripetal force required for this tiny piece is equal to, we can write f df is equal to m omega square r. So dm omega square into x, dm we can write it as mass per unit length. Clear? So lambda into dx omega square x. So we get lambda omega square. Integrating this expression to give complete forces, x dx will give you x square by 2, which is integrate from 0 to L. So we get L square by 2. And we know lambda into one of the L among this will give us mass. So the answer is m omega square L square by 2. Not L square, L by 2. M omega square L by 2. One of the L is already taken. They're asking what is the value of alpha, that we have to rewrite this equation over here. Angular velocity of the tube is, so omega is equal to 2f by mass into length. But what is the mass given? Mass is given as 2m. Length is 1. So omega is equal to 2f by 2m into 1. 2 gets cancelled. We get, this is root of, we get root of f by m. That means the value of alpha is equal to 1 here. Clear? That's it. Okay, here we are. The last question, the net current in the circuit is, all right, look at this. The capacitor will not allow the current to pass through. So this is breaking the circuit. Breaking the circuit. The capacitor gets fully charged, it will break the circuit. That means the current which reaches over here will not pass through this. And for a moment, now think about this. If this particular part of the circuit is broken, totally gone, there is a gap here. There is a gap here. And if you redraw the diagram, cell, resistor here, a resistor here, and a resistor here. So this is 4, 2, 3. And then we have a 6 ohm here. 6 ohm. After that, if that circuit is broken, we have a circuit over here, a loop over here. In fact, to be precise, I have a loop over here which has a bunch of resistors. But look at this. The current will simply not pass through this particular part. You can see that this is completely detached from the source. Like you can completely detach from the source over here. So the current that enters will get divided here, and then it will turn back over here. It will not pass through this. Clear? Because this doesn't become part of the circuit. It's not part of the circuit. If there was a wire here, then the story was different, then the current is passing. Otherwise, it is not part of the circuit. So that means we have to consider only these. So 6, 3 parallel will give you 2 ohm. Effective of this is 2 ohm. 2, 2, 4. 4 and 4 parallel will give you 2 ohm. So effective resistance is 2 ohm. Potential difference is 2 volt. Current should be 2 by 2, 1 ampere. So that is the answer. The net current flowing in the given circuit is 1 ampere. And that's it. That's all the question is all about. All right then. Thank you. Have a nice day.
Brilliant Study Center, India's #1 coaching center for NEET and JEE.